Hello guys, welcome back. So today we'll start on the data engineering program. So we have PySpark in the data engineering series. So this is a part of our data engineering program and tutorials that we are creating. So we'll start with this. Now what is PySpark and how it's related to the big data? And before going to that, we'll start with big data. Now what is big data? Have you ever wondered how companies like Amazon, Netflix, Google process billions of records in seconds? How does Instagram analyze millions of posts in real time? And why Apache Spark is the most in-demand skills for data engineers today? In this video, we are going to deeply understand about big data and Apache Spark from the scratch, with some real-world examples as well. No confusion, no theory overloaded. But yes, we'll start with some of the basic theory because some of the people who are going through this video might not be aware of the big data concepts. So I will touch upon the big data concepts, but before touching on the big data, let's start what is big data. Now at its core, big data refers to the data sets that are too large, and rather than being too large, it's, I would say, too large and too complex for traditional data processing applications like Java, Spring, or any other application software that is built on. It's just not about the sheer amount of data, but also it's about the complexity of the data, and moreover the speed at which it's generated and the variety of format that it comes in. So assume traditional tools like relational databases like Postgres, MySQL, and standard desktop softwares often struggle to store this kind of data across and perform massive operations on the top of this data, right? So assume you have an Instagram and there are a lot of data that comes in. So in Instagram, in 1 second, maybe some terabytes, not even terabytes, I'm talking about petabytes. So that's the volume of data that grows from GB to TB to PB, and that's what we say about volume. So, and the date rate at which the data comes to us is the velocity of the data, right? So easy examples are basically the social media feeds that we see, right? So think about the content streaming of posts, images, videos, even if videos, likes, share, comments. These are all generated in real time, and the volume is massive. It arrives incredibly fast, and it's a mix of unstructured and structured data both, right? Now, understanding the user sentiment, identifying the trending topics, targeted advertising, detecting fake news, these all are basically a part of the big data, right? Let's talk about the e-commerce transactions and the click streams. So an online retailer like Amazon and records every product viewed, added to the cart, or the purchase made, the search criteria, the search pattern, the mouse movements, everything is stored in Amazon, right? And these are not mere big data. These are millions and millions of customers and petabytes and terabytes of data, and it's mostly track each and every second that you're using the system, the Amazon system. Now why it's big data? Because the high volume of transaction recorded and even the higher volume of click stream events the user is doing on the Amazon page. So data arrives in very real time. It arrives very fast and with the large number of velocity. It includes structured purchased data, semi-structured data, unstructured reviews and comments. So the potential value becomes the personalized recommendations that Amazon provides to its users, right? So these are the potential value that Amazon gives to our users as a part of their big data, right? So now we'll just go ahead and identify the characteristics of big data. I hope you understood what we are talking about the big data. Now we will understand the characteristics of big data and what is exactly a big data, right? Now the defining properties of big data are often summarized using several V's. So when we talk about the V's, basically there are three main V's: velocity, variety, and volume. But additional to that, volume, velocity, variety, veracity, value, variability. So value, volume, velocity, variety, veracity, variability. So these are all the V's that decides if this data is a big data or not. Now I'll talk about the value. The usefulness and the potential insights that Amazon generates from its user data, right? The value that it is giving to user. It uses those data to improve the navigation in the websites. So that is the value that Amazon is providing with their data. Data is only valuable if it can be turned into an actionable item from the user perspective, or an actionable price, right? It should generate some value as an Amazon company, if you think about Amazon, right? So now I'll talk about the volume. I have already talked about the volume, the amount, the sheer quantity of data that has been generated and stored and measured in terabytes. Not even terabytes, I'm talking about petabytes, right? Let's take an example over here for the data, the daily photos that gets uploaded to Instagram. So these are high throughput data. When we talk about next, let's go to the velocity. I hope understood the volume. Now let's go to the velocity, the speed at which this data is generated and needs to be processed. It often requires real-time and near real-time processing. That is what we are talking about big data. It is the high-speed processing. That is what the velocity, right? And we talk about the variety. Now variety is basically, I have already told, as if social media post, it can be image, text, video, etc., right? So there are different varieties of structured, unstructured, semi-structured data that comes in. So I need to handle all of this to generate some value, right, to my customers. If you think about Amazon, I'm just taking an example of Amazon because Amazon is very classic to this. It's very easy to help you understand using the example of Amazon. When we talk about the veracity, the uncertainty, the quality and the trustworthiness of the data. Big data can be messy at times, right? It can be inconsistent, it can be incomplete, and it can contain biased information as well, right? So for example, if you're reading multiple readings from multiple weather sensors across the world, and there are different calibration issues on those weather data, right? So that is where the veracity comes into the picture. Now user has generated some reviews. Let's take the Amazon example. Our classic Amazon is our target as of now, so we'll take Amazon as an example. So let's say the user who are generating the reviews, that reviews could be biased, it could be fake, it could be maybe manipulated. So that's where we talk about veracity, right? Now when we talk about veracity, we talk about variability as well. Now with variability, the inconsistent of the data, the flow rate or the format, it could be daily, it could be weekly, it could be at times in daily there might be less data coming in, but in terms of the weeks or the Saturdays, Sundays, weekends, the spike might be too much in the online shopping or the Amazon world, right? So these are the seven V's that defines the big data concept. That is where we say, okay, it's a big data, right? The characteristics of this big data leads directly to significant challenges, right? Now if I need to store this data, right, there are a lot of challenges in storing, processing this data. The storing a petabytes of data or terabytes and petabytes of data efficiently and cost effectively requires a lot of storage. Not only one system, it could be multiple system or a distributed file system like HDFS or a cloud storage, right? So traditional single server storage is not sufficient for this kind of big data, right? And when we talk about the processing, analyzing these massive data sets of data within a reasonable time frame requires distributed computing power. Like processing on a single CPU machine is not possible, it's near to impossible, I will say, for this big data. Now when we talk about the veracity, which we have talked about, the data quality also matters and cleansing the data also matters, and that has to be done with complex time. It takes time to process and cleanse those data, right? And security and privacy comes into the picture. Combining all those data and generating a meaningful extract or a meaningful analytics is also a challenge, right? So these are some of the challenges with the big data, right? Now for talent is also a problem with this, because you will really find talents for this kind of jobs. Yes, I know there are a lot of market demand with the big data, but you need specialized tools, you need skills, you need data scientists, you need engineers, you need analysts to do all these things. So it's a costly process, if you see, right? Now here comes Spark. There comes the Spark in the Spark world. If you see, Now I'll compare this with the Spark. I have not still went to the Spark. So if you see all these data challenges that we have, right? So for these data challenges, the big data that has, so we have two solutions in the market. One is the Hadoop and second is the Spark. Now in order to tackle all these challenges, Hadoop specifically using a MapReduce component, which was pioneered open source solution earlier, and Apache Spark emerged a bit later, addressing lot of the MapReduce's limitations, particularly in terms of the speed, because we have big data. Now we need speed. Speed is the core of processing the big data, right? Now I'll talk about a bit about the Hadoop MapReduce over here, right? Now Hadoop MapReduce, a programming model and a processing engine for distributed batch processing for the large dataset. It breaks down a large task into smaller independent tasks and then it aggregates the results. That is what we call as reduce, right? So I have just touched upon the MapReduce. If you have worked on MapReduce or you know about MapReduce, that's great, but you'll not need much of a MapReduce in the Spark world. I'll just given it for your understanding purpose. Now the processing flow, I will talk about the processing flow of the MapReduce, how it happens, right? We read the input data from HDFS, the Hadoop distributed file system, and we have the mapping phase. We apply a function to each input, generating the key value pairs, and the results are typically written to the local disk in this case, in the MapReduce. So this is important over here. I'm just trying to highlight that the data is writing into the local DB. Then there takes a shuffling and the sorting. The intermediate results are transferred across the network, sorted and then grouped. This also requires significant I/O operations, correct? Now once the data is reduced and sorted, not shuffled and sorted, it comes to the reduce phase. Now we apply a function and we generate the final output and write that final output to the Hadoop distributed file system. This is a typical Hadoop MapReduce looks like. But if you take about Spark, it is generally a fast general purpose cluster computing system. Most of the operations that happens in Spark is in memory. Okay, it provides high level APIs using Java, Scala, Python, R, but in case of Hadoop, it's mostly Scala, it's mostly Java. It's sorry for this because Hadoop it is mostly Java, and Spark you can write Java, Scala, Python, R and other things as well, right? The speed at which Spark processes and the speed at which Hadoop processes the data is 100x times faster, that we can say. The data processing happens near real time or interactive iterative in batch as well, but in Hadoop it is always a batch processing. The ease of use, if you see, in case of Spark it's very easier and compact to use as in compared to MapReduce. Like in terms of the caching, you can cache the data in memory in case of Spark, but in case of Hadoop we cannot cache the data in Hadoop, correct? So now I'll talk about the processing flow as well. We read the input data from the HDFS database cloud storage, and then we take those data into an RDD, that is the RDD systems. I'm sorry, let me see. I might be fast, so just bear with me. If you think anything is wrong or you're not able to understand, you can pitch in between. Okay, so we'll first read the input. This is the input we'll see. This is the input. We read the input, right? And then what we do, I'm talking about the Spark, okay? Because we are going to talk about Spark a bit more, so I'm just talking about Spark. So we read the input, right? We apply a series of transformations. Okay. Now once we read the data, input data, we convert this input data. Basically this input data is stored in RDDs, something known as RDDs. I'll talk about this later when I go into depth. I'll just give you a flow. We apply a series of transformations, and those transformations those happens in the in memory or using a concept known as DAG. You just remember these words. We'll talk in detail in the next series. Okay. And in the transformations, what we do operations generally like map, filter, right? And then we do operations like group by. All these we do using these are all transformations. Basically each and every transformations creates a new RDD, data frames, or data frames we can call it, from the existing data. And these are all lazy, Spark builds up a DAG based on these transformations, but it doesn't execute them then and there. There is a separate way where it executes. Now once the transformations are done, so what happens is, once the transformations are done, we trigger actions like what are the actions? Basically we have few actions that I can talk about now. The count, we have few more, collect, we have save, and we have for each. I mean, these are some of the actions that is present in Spark, and this initiates the computation defined by the DAG. We have created a DAG over here. Spark, I'm not taking V, Spark creates a DAG, and that computation is initiated once we trigger these actions. Now all these things that is happening, you don't need to know everything as of now. I'll talk about each and every step in detail in the next video on the Spark architecture. So primarily the processing happens in the in-memory, right? Spilling to disk only if it is necessary. It reads the data into the memory first, caches it, the intermediate results into the memory across the DAG or the stages, I will say, and it significantly reduces the IO operations if you compare it to MapReduce, because MapReduce writes into the data, writes into the disk, and then again takes it and again then reads, right? So this makes Apache Spark much faster. It often quoted as 100x, 10 to 100x for many workloads, right? So that is the reason you see Spark is being used in across all the places like machine learning, deep learning, everywhere you see Spark, and that is the reason why people use this Spark, right? So I hope you understood. Now I'll talk about some of the smartest things that are built on the Spark ecosystem. Apache Spark is not just about processing, it's also about basically the Spark is built to be a uniform analytics platform with several components inbuilt, like Spark SQL, Spark streaming, MLIP for machine learning, GraphX, Spark R, right? All these are given as a part of the Spark ecosystem. And we have the Spark core library or the core APIs, which is R, SQL, Python, Scala, and Java. You can use any one of them as well. You can use with any. I'll not go into more detail, but I'm just giving you just overview so that you are aware of all this, right? So GraphX is for graph processing, and if I say MLIP, I told you it is only in machine learning. This is a Spark streaming. It enables a scalable, high throughput live stream data. You can use it using this, right? And then comes the Spark SQL. We all know Spark SQL is basically working with the structured data, data frames, data sets, all those things. And then but the basic foundation is always the Spark core, right? These are all Spark core APIs. It provides distributed task dispatching, scheduling, IO operations, core RDD abstractions. All other libraries, whatever we see, are built upon the Spark core, right? You can implement a basic ETL task using RDDs as well. So these are some of the examples you can try. You use in R, Python, Scala, Java. So all these things are possible in Spark, right? So we'll mostly talk about using Spark with Python, because the Python is the language that we are targeting for the data engineering, and we'll continue using this in the next lectures. I'll talk about the Spark ecosystem, Spark architecture basically in the next tutorial. So let's summarize what we have done. Let's summarize what we have till now discussed. So big data is just not big data. It has a key characteristics: volume, velocity, and variety, along with some additional aspects like veracity and value. which makes it challenging to manage using traditional data systems, right? Now, handling big data comes with a lot of challenges, including the storage, processing, security, data management, quality, etc., right? And Hadoop MapReduce played a crucial role in the early big data ecosystem, often required, mostly used for batch processing, and then it has been seen a lot of performance limitations due to heavy disk operations. Right now, to overcome these limitations, Apache Spark was introduced as a powerful and fast alternative that we see today. Spark has been used in most of the places in data engineering roles, and wherever you go, you'll find Spark. The first thing people will ask you about, how you do know Spark, right? And Spark is based on few concepts, so RDDs, the data frames, datasets. It also provides a unified analytics platform, which we have seen at the end of the slide, right? Spark SQL, Spark Streaming, MLeap, all these are a part of the Spark ecosystem, and these all are built on the top of Spark core engine, right? So I hope this lesson has helped you. At least I know it's a bit theoretical, but I believe it will help you to understand the Spark, the big data challenges, the modern distributed processing, how PySpark is important, why we need to use PySpark, or basically Apache Spark. So I hope you have enjoyed it. Let's wait for the next tutorial. That is going to be a bit more exciting, because we are going to talk about the Apache Spark architecture over there, and that is what you should take your headset in a focused room and try and understand what I'm talking about, because that is one of the most important aspect of Spark. If you want to know Spark, you need to understand that. So thanks for watching this. Let's come back tomorrow with a new session. Thank you so much.